Identifying the degree and leading coefficient of a polynomial function. Because of the form of a polynomial function, we can see an infinite variety in the number of terms and the power of the variable, although the order of the terms in the polynomial function is not important for performing operations. We typically arrange the terms in descending order of power, or in general form. The degree of the polynomial is the highest power of the variable that occurs in the polynomial. It is the power of the first variable if the function is in general form. The leading term is the term containing the highest power of the variable, or the term with the highest degree. And the leading coefficient is the coefficient of the leading term. So the terminology of polynomial functions. We often rearrange polynomials so that the powers are descending. So a subscript n in this scenario represents the leading coefficient. The blue represents n is the degree, and the entire function is called the leading term. So when a polynomial is written in this way, we say that this is in general form. So given a polynomial function, we want to be able to identify the degree and leading coefficient. Number one, we find the highest power of x to determine the degree function. Number two, we identify the term containing the highest power of x to find the leading term. And then number three, we identify the coefficient of the leading term. So in example 5, we're going to identify the degree and leading coefficient of a polynomial function. We're going to identify the degree, leading term, and leading coefficient of the following polynomial functions. So let's take a look at the first function. If we look at the first function here, we need to figure out which term has the highest degree. We can see here that this is the term with the highest degree. If we take a look at g of t, which is the term that has the highest degree? Well, we can say that's 5t squared. And if we take a look at the last function, h of p, we can say that nev minus p to the third power is the leading term. So one way of recognizing this is that we can reorder this. So we can say that this is f of x is equal to negative 4x cubed plus 2 plus 3. And over here, we can see that this is already in the correct form. So 5t to the fifth minus 2t to the third power plus 7t. And then over here, this would be negative p to the third power plus 6p minus 2. So again, we're concerned at looking at the leading coefficient. So for the function f of x, and I'll highlight that here. So for the function f of x, we can see that the highest power of x is 3. And so the degree is 3. We can see that the leading term is the term containing that degree. So the leading term is negative 4x cubed. So the leading term is negative 4x cubed. And the leading coefficient of that term is the value of negative 4. So therefore the leading coefficient is negative 4. Okay, let's take a look at the next function. So the function g of t, we can see that the highest power is t. Of t is 5. So since the highest power of t is 5, so therefore the degree is 5. Now the leading term is the term containing that degree. So we can say that 5t to the fifth power is the leading term. And then the leading coefficient is going to be the number in front of that. So therefore the leading coefficient is 5. Okay, last one. For the function h of p, the highest power is positive 3. So if the highest power is positive 3, we can say that the degree is 3. The leading term is a term containing that degree, so it's this entire term. So the leading term is negative p to the third power. And the leading coefficient is what we have in front of that, which is a negative, and you would imagine that as 1. So the leading coefficient is negative 1.